the one that's still going off.
When they go around, it goes away.
What is it?
Like fully.
Oh yeah, you see both of the boosters. Yeah.
Yeah, maybe it's like a UFO. That's this guy's.
Yeah, so it's a Falcon Heavy.
Yeah.
Wait, you know
Falcon Heavy is doing a fairly light payload.
Wow.
Wait, look at that. Look at me. That's sick.
Ooh, beautiful.
Wait, Theta? Is that Theta?
Yo, I'm done Theta.
Theta, bro, Theta.
Wait, that looks like Saturn. Am I tripping? It looks like a planet.
It looks like the black hole from Interstellar.
Dude, that's what I was thinking.
And then
black hole, yeah.
like red dark spot there.
I don't know.
They did it in like high altitude winds, because high altitude winds are fairly constant.
Wait, what was that red spot on the right?
Is it actually red or is it just?
No, it's red.
It's red.
No, it's from the sun.
Yeah, it might be from the sun.
No, it's probably not.
The bottom is redder than the top. I think it's just a lighting article.
It is just the sun.
I
Yeah.
think it's at like higher altitude or something.
It's shaft color sun.
Lower, no?
Wait, or it could be a concentration.
Because red.
The sunset, like.
You're right. It might be lower, so it has more Rayleigh scattering.
Yeah.
Man, you guys are smart.
Wait, it gets
It
close to yellow at the bottom.
Is that because the different layers?
So the frequency of the light.
Yeah.
Mm.
And they definitely went in the high atmosphere.
Yeah. I mean, yeah, there are definitely. Yeah, I could see how that would happen, like boundary layers between.
Yeah, because that was dimming.
It was different.
This trap color is not just.
Wait, what do you think is the height difference between light?
Well, you see the central lines is still illuminated quite well. So
Yeah.
I don't know. That could be the highest point.
Ironically,
Right? Man's right.
Oh, wait, how did the circle around it get there? From the app?
The booster that left did a spin motion, and there's like very
Okay.
little air currents up there.
Oh,
so
yeah,
sometimes
Yeah. So and
you're-
then spun, and
then
then when it
kept
does,
going.
it does the thing. Yeah.
Yeah.
Well, yeah.
True.
And then it just spread out. But how did it loop back down?
What do you mean?
It's not that.
Maybe it's not.
Oh, the booster probably did it.
It's probably a
Booster probably did its thing at a
That's
slight
pretty good.
angle. And so
No, but
Yeah.
pointing-
I get why. Like if you look,
No, you
it
have
does
to-
that. But why does it come back down?
because the booster made like a circle that just kept expanding.
It could also be just perspective. It could
That's yeah. It could like
be on a
like
plane
just-
where the.
Yeah.
But the plane flew that way.
Yes, it
Or it could
went.
have flown that
Well,
way.
There's also wind.
like
There's also
this.
wind.
Yeah.
No, I'm saying like the plane of
What?
like the actual like
This isn't a
speed.
No, but the plane could have gone
Is it?
that way,
I wanna
and
make
that's
up-
why it's a circle.
I don't know.
Because it's actually like,
Why?
yeah.
Because why would they do it over a city?
No, it's there's a space station like north.
But it was in that way.
west of.
Doesn't it land on a ship?
It
yes.
does.
Yes, it does.
Oh,
Although, what orbit does that get you into?
here I don't know.
The ocean's that way. The whole Pacific Ocean.
It could be longitudinal though.
True.
Like longitudinal, you can start from anywhere.
If they're doing Starlink, it's the low Earth orbit, right?
Maybe.
Yeah, but I don't think it was
But Starlink launches everything in Houston
Two, I feel like that's the
or Florida.
Stuff out of here before, because I remember
Yeah,
seeing a bunch of
You're
Starlink.
supposed to
coming out.
launch into the east, right?
Spaceship.
Well, we're on the west coast. They were
Yeah, so I don't know
go
what
west.
Starlink though.
Because Earth
You do have to go west. Goes
Going
up
west.
and
I
up.
have to see what they launched today.
Wait,
No, but like,
So it does. It would go that way or not? West to
Because
east.
this way you're using the momentum. That
Yeah,
way
you're using the momentum of.
I see. I see. But that way could be for a geostationary orbit.
Yeah.
though.
No,
Mm,
no,
You
that's
would-
not how geostationary orbits work.
Never mind.
Yeah, that's a Lagrange one.
You could do it for polar.
Oh yeah.
Pretty cool.
Mm.
That's why you.
That's the wrong direction.
yeah, they launched in the wrong direction to get the system to Earth. So they must be going into a weird.
It
Yeah,
have-
that's
oh,
flying south. They're going into a polar orbit.
Yeah, it's polar.
It's a polar.
South.
An orbit. So the Earth orbits like this.
Yeah.
The polar orbit goes like
Can
this.
just get this off.
Oh, so you don't care about your.
Less so. Yeah, certainly less so.
you're not fighting as much against it.
Yeah, it certainly helps if you can like launch at this angle to get like a small gravity assist that you can then like course correct later. Not a gravity assist, it's just like
Aerospace is so cool.
it is.
Hey,
That's why I'm going into
we are
aerospace.
working in aerospace, right?
Yeah, electrical engineer at aerospace.